All right, so we are now looking to actually find this fine number summary, right? We're trying to figure out how we can divide the data into four equal parts, right? Where 25% of the data lives in the first quadrant, right, between the minimum and Q1, the second quadrant between Q1 and the median, the third quadrant between the median and Q3, and the fourth quadrant between Q3 and the maximum, right? Now, there's one of those in there that we know already, right? We know that the bottom 50% in Q1 and Q2, the first two quartiles, are going to be below the median, and the rest are going to be above the median, right? So it makes a lot of sense that we can use a median function that we already have, right? So let's go ahead and just first thing that we do, or I guess before we do that, I want to show you, I just built a data set of 1,000 random numbers between 0 and 100. If we look at this data set, we can see that there are 1,000 random numbers between 0 and 100, right? So that's what we're going to be finding the median of, right? We're going to expect this to be evenly distributed throughout the four quartiles, right? So we're looking for a Q1, a minimum around 0, a Q1 around 25, a median around 50, a Q3 around 75, and a max around 100, right? Now, the low-hanging fruit, right? A minimum, right? I've got a min function. Easy enough, right? I've got a maximum. Easy enough. I've got a max function built in to base Python. No imports, nothing necessary, right? I can also, right, find my median pretty easily. I've imported NumPy here. I did that to make my data set to use the NumPy random module. So I'm actually going to use numpy.median, right? And then let's go ahead and just give ourselves a little print statement here, right? Let's say min max. And what else are we showing? We're showing the median right now. Let's go ahead and just add these in here. I know where we're going to need them. Actually, let's leave them out for now. Right, let's make this an F string. And here we'll actually put our min. In this F string, we'll actually put our max. And in this last string, this last F string, we'll actually put our median, right? Let's go ahead and save that. Let's give that a run. And I'm going to get rid of this for loop. I just had this for loop in here. So we could print out all those numbers, but it's making things kind of hard. Also, I'm going to set my seed again, so I can make sure that I'm looking at the same numbers each time. Clear that out, right? So here I can see my min is 0, my max is 99, my median is 48. Those are approximately what I was expecting, so we're off to a good start. Right now what we need to do is we actually need to divide the data into a lower subset and an upper subset. Once we've done that, all we need to do is take the median again, right? So how we're going to do that is, right, we're going to use just list indexing. So if I say my low subset is going to be equal to random nums, right? But what am I going to want to do before I start making these subsets, right? I need to sort the list, right? So let's say sorted random nums equals sort of random nums, right? Now, sorted, excuse me, right? Now that I've got these sorted, which is great, now I can divide, right? Now, if I think I've got length of 100, if I do floor division, that's going to give me 50. I'm looking for the indexes 0 through 49. So it seems like I can almost say that my low subset is going to be equal to my sorted random nums, right? starting at the 0th index, and then the finishing number is the length of that list, right? Floor division by 2, right? So that would work if and when I had an even number, right? But when I have an odd number, I'm going to have to do something different, right? So let's say if the length of my numbers is evenly divisible by 2, then this is the operation that I'm going to want to do. Otherwise, and then, you know what, I can go ahead and say that my high subset is going to be most of the same stuff, right? This time, however, it's going to start at that value and end at the end of the list. I put a 0 there. It just needs to be blank, right, to go to the end of the list, right? Now, otherwise, I'm going to need to find what we're going to do is we're going to take the subset. Let's find the midpoint. So if I have a list of length, let's use a small number, length 9, then 5 is the 5th item is my median, right? So I want to exclude that number, that number that's exactly in the middle. I don't want that in either my upper subset or my lower subset, right? So what I need to do is if I do floor division on 9, I get 4, and the 4th index is the 5th item in the list. So I do want to not include that. Actually, let's skip the midpoint, right? Let's say I think my low subset is going to be the same, right? Because that floor division is helping us out. Right? Now my upper subset is where things are going to change a little bit, right? And that's going to say, you know what? Now I'm going to want to do this same thing. But what I want to do is I want to add 1, right? Because if I started right here, I'd be starting at that middle element. I don't want to start at that middle element. I want to start at the element after that middle element, right? So I don't need them, but I'm going to put in some parentheses here, you know, just in case, right? And now I can actually say, you know what? And then I'm going to rearrange these so they're in order, right? I can say that my Q1 is actually just going to be the median of whatever my low subset is. And Q3 is going to be whatever the median of my high subset is, right? So to get into evenly spaced 25% buckets, right? We first divided into two 50% buckets, and then we've taken those 50% buckets and divided those each in half at the 50% mark, right? So we have half and half. But now let's go ahead and we'll print Q1. I'm going to take max over here to the end. Then we've got the median, that's great, as it is. Right, then we've got Q3, and I think what we're doing for Q3 is simply Q3. Now I think I'm in good shape here. I haven't tested this, so we might have a little debugging to do. Looks like we're actually in good shape here. And this comes out, you know, with numbers that are really close to what we'd expect, right? A min at 0, Q1 at 25, a median at 48, Q3 at 75, and a max at 99. there is a way to do this in Python, right? And you might want to do that using the percentiles coming out of NumPy, right? We can just real quick, I'll come over and steal this code from this lesson, right? Let's go ahead and comment all of that out, right? And we could say, the min, this doesn't have the min or the max. And I was using capitals, so we'll change these to capitals. This is np.percentile, right? We're talking about this. The way that NumPy calculates this is actually just a little bit different than what we are used to seeing, right? When we do it with pencil and paper, when we use our median method. So the values here are likely going to be slightly different, but the data will be divided the same, right? Let's go ahead and see if it's different before we talk about it too much. Looks like min is not defined. Looks like I had some unsaved changes. So in this case, it actually gives us the same exact results because there are data points actually at those. If you have a really large data set, right, typically your median, your Q1, and your Q3 will often come in between data points, and it'll calculate those differently. And what's actually happening is where we didn't put that middle value into either data set, right? I think NumPy puts it into both data sets. So the value ends up being different, but the data ends up being separated the exact same, right? So that's how you can find the median, the 5-number summary in Python, both an easy way using the NumPy percentiles, or from scratch if you were to maybe write your own function or something like that that's shown in the lesson. So that's it for this video. Make sure to hit like and subscribe, and we'll see you over in the next video where we talk about variance and standard deviation.